This circuit utilizes a 1000 microfarad electrolytic capacitor to power a yellow LED and a green and red bicolored LED, while the main power from a 9-volt battery is cut off. The circuit is enabled by the use of a PB&O switch to split current between two 470 ohm resistors in parallel. The bottom resistor feeds current into the capacitor at a rate that will slow down the rate of charge and discharge of current coming in and out of the capacitor to a time of 2.5 seconds. When the red bicolor LED turns off, the capacitor has charged. As the capacitor fills with charge, current flowing through it will slow down. This is due to the resistance being infinitely increased as the capacitor fills. Once the PB&O switch is open, current no longer flows into the anode of the capacitor, and it can release its stored current through the circuit. The current runs the opposite direction, flowing through the 470 ohm resistor into the yellow LED and then into the bicolored LED's green LED inside. The capacitor quickly drains its energy, and both LEDs go off. The second PB&O switch is placed to drain the capacitor immediately. When it is pressed, it connects the positive end of the capacitor to the negative end of the capacitor. This quickly discharges the current as it chooses the path of least resistance and brings the capacitor to a neutral charge. The parts used in this circuit were a breadboard, one yellow wire, a green and red bicolored LED, a yellow LED, three 470 ohm resistors, a large PB&O switch, a small PB&O switch, and an electrolytic 1000 microfarad capacitor.